Math contest problem number 40. Roots of a complex number. A student writes the 6 complex roots of the equation z raised to 6 plus 2 is equal to 0 on the blackboard. At every step, he randomly chooses two numbers a and b from the board, erases them, and replaces them with 3ab minus 3a minus 3b plus 4. At the end of the fifth step, only one number is left. Find the largest possible value of this number. Complex numbers are in the form of a plus bi, where a is the real number and bi is the imaginary number. So we have this illustration of complex numbers in graph. R is called the absolute value or the modulus of the complex number a plus bi. So this is R here, in which R is equal to square root of a squared plus b squared. Theta is called the polar angle. This one here is the polar angle or argument of the complex number a plus bi, in which theta is equal to arctangent absolute value of b over a. A plus bi is plotted as a point. So this point here is the a plus bi. Z raised to 6 is equal to negative 2 or negative 2 plus 0 I, where a is equal to negative 2 and b is equal to 0. Solving for r, we have r is equal to square root of negative 2 squared plus 0 squared is equal to 2. And theta is equal to arctangent 0 over negative 2. The absolute value of that is 0, which is equal to 180 degrees or pi radians. So the illustration is this. So this is how we plot negative 2 in complex plane. So negative 2, because this one here is negative 1. Now r is the distance from this point to the origin. So that's r. R is equal to 2. And the angle, the theta, the argument, is the measure of this from this initial point to this point. So that angle is 180 degrees or pi radians. In getting the roots of complex numbers, first we need to change its rectangular form a plus bi to polar form. This is how we are going to do that. A plus bi is equal to r cosine theta plus I sine theta. This is the polar form of the complex number, where theta generally is theta plus 2 pi k. K is equal to 0, positive negative 1, positive negative 2, and so on and so forth. So negative 2 is equal to 2 cosine pi plus 2 pi k, because theta is pi and r, the modulus, is 2. I sine pi plus 2 pi k. So that's negative 2. So negative 2 is in rectangular form. This one here is the polar form. Since z raised to 6 is equal to negative 2, finding its roots, we have z is equal to negative 2 raised to 1 over 6. And because negative 2 is equal to this one, we raise that to 1/6. We will also raise this to 1 over 6. Now, using the Moivre's theorem, cosine theta plus I sine theta raised to n is equal to cosine n theta plus I sine n theta. So negative 2 raised to 1 over 6 is equal to 2 raised to 1 over 6 cosine, we multiply this and the 1/6, so the result is pi plus 2 pi k over 6. I sine pi plus 2 pi k over 6. where k is equal to 0 up to 5. Why? Because there are 6 roots. So from 0 to 5, there are 6 numbers. Substituting k is equal to 0 to 5, we will get the 6 complex roots of z raised to 6 plus 2 is equal to 0. And the 6 complex roots are this one here. Positive negative I, 6th root of 2. 6th root of 2 times square root of 3 positive negative I divided by 2. And then 6th root of 2 times negative positive negative I all over 2. So these are the 6 complex roots of this equation. Now, to end up with a largest possible number, because we need to find the largest possible value. At the end of 5th step, we need to eliminate imaginary numbers. So this one here, these are imaginary numbers. And radicals. So the radicals, we need to eliminate them. And to do that, we should operate conjugates. Conjugates just like this one, positive and negative of this, then positive or negative of that, to remove the radicals and the imaginary numbers. Now let's have this 3ab minus 3a minus 3b plus 4. We will simplify this to 3ab minus 3 times a plus b plus 4. Let's have step 1. Let a be equal to I, the positive one, 6th root of 2, and then b is equal to negative I, 6th root of 2. Solving for this, substitute, and we'll end up with 3 cube root of 2 plus 4. So this is the result after step 1. Let's have step 2. We'll take this roots. We substitute 3ab minus 3a plus b plus 4. Simplifying all of that, we have 3 cube root of 2 minus 3 square root of 3 times 6th root of 2 plus 4. This is the result of step 2. Next, for step 3, we take the last 2 complex roots, and then we substitute 3ab minus 3 times a plus b plus 4. Simplifying that, we have 3 cube root of 2 plus 3 square root of 3, 6th root of 2 plus 4. Now, to easily operate steps 4 and 5, we simplify 3ab minus 3a minus 3b plus 4 to 3 times a minus 1 times b minus 1 plus 1. Let's have step 4. So let a be this one from step 2 and b be this one from step 3. Substitute 3a minus 1 times b minus 1 plus 1. Simplifying all of that, we have 27 cube root of 4 minus cube root of 2 plus 1 plus 1. Finally, let's have step number 5. Let a be 3 cube root of 2 plus 4 from step 1, and b be 27 cube root of 4 minus cube root of 2 plus 1 from step 4. So this one here. And then we operate 3 times a minus 1 times b minus 1 plus 1. We have this plus 1 plus 1. Simplifying all that, we have 730. And this is the largest possible value.